I think the unique feature for this is that you're storing the past records. So the main focus is like having these two values that sum up to the targeted value, right? And like I said, the unique feature is storing the past records. And how you are gonna abuse it is that we need to backtrack on what is like the fundamental principles that we are having. So it's basically talking about having your first value plus your second value and equals to the target value. And past record means that your one value will most likely be within the past records. And the loop will actually end once you hit the second value, because your number one value will definitely fall under the category of the past records. So in other words is that if you have these two values, the sum up to target, the moment you hit the two, just say if for example like two of the values will be within the scope, within the realm, that it always happens when you hit the second value, you end off the loop. And you can argue on the opposite side, why not hit until the one, then straight away get the target value? It's because we haven't even taken into consideration until the value that's after. We only am actually able to take record of values that is before, based on the feature that we are utilizing, which is that it only can check for values before, but not so much about after. So if your value can only check for before and cannot check for after, they wouldn't know that like this number two do exist. They only will know that the values that it's like before exist. So in this very case, they don't know that the two exists. So one way to actually solve it is that you have to move until the second value, so that you know that where the one do exist, and it's actually right over here. And how do we actually make all this possible, that it will check all your previous value? Is by using this hash map. Because it's, to me, this hash map is like a book, and it will keep on adding records inside. So anytime you go along like the values over here, you keep adding back to the record. It will sort of store history document in it. So I think that's how the hash map actually do work. Like each time it passes through one value, it's gonna store the value in it. It's gonna register where the index is, what the value is, what the index is, what the value is, what index number it is, what value it is. And kind of like rinse and repeat. And so the moment it hit until number 2, it will check back the records of the previous, which is in this sort of like a hash map. And maybe say like the number 1 do exist as index 2. So you see that, or on index 2, I do have like the 8 value that I need to actually solve. Maybe say they needed the 8 over here. And with your current number 2 value, it does add up to your target value. And at the very start, it did talk a lot about the naive way of solving the solution. So say for example, you have a target value that you want to hit. They say that you can actually do the brute force, so you go by the set. Maybe say for example 5 is the value that you want to hit. So 6 minus 1, you land until the 5. So there you have it, that's the answer. And you achieve it through this method of brute forcing. So it's basically taking the values of like 3 plus 6, 3 plus 5, 3 minus 1, 3 plus 2, and 6 plus 5, 6 minus 1, 6 plus 2, so on and so forth, rinse and repeat. And you're taking the combination of the whole of 3, the whole of 6, the whole of 5, whole of -1, and 2. And for the combination for 6, you don't really need to travel back to 3. It's because it's already been covered, as you see. 3 plus 6. And similarly, in 5, you don't have to go back to 3. It's because 3 is already covered by 5. And if you were to see, 5 doesn't need to go back to 6 because 6 already covered for 5 before. So if we were to go to -1, let's go to 2, right? Why you don't need to go back to 5? It's because for 5, you already cover for -1. So if you were to see there's like a sort of a trend that's actually going on, that you don't really need to cover back up into like the previous values for the 5, for the 6, for the 3. Just need to look forward, because whatever is that need to go previous, it's already been covered in the 5 combination, in the 6 combination, and in the 3 combination. Back to the main idea, which is to getting to the target value, which is the number 5. It's 6 minus 1, and then we sort of like found our answer. And this method that we are actually using is actually true brute force method, and it's the naive way of like approaching the problem. The time complexity will definitely be big O of n squared, where the size of the array is n, and that you need to multiply by another n. It's because of the combination of like 3, combination of 6, combination of 5, combination -1, and combination of 2. So as opposed to having like u multiplying by just n. So let's discover the flip side. We discovered n times n. What's n? So the number 2 is actually talking about you run through the array just once. So a time of like 3, a time of 6, a times of 5, a times of -1 or 2. And that will be n. And it's just doing one sweep. That is n. But for number 1, it's n times n squared. It's because it's a combination of 3, which is basically 3 plus 6, 3 plus 5, 3 -1, 3 plus 2, 6 plus 5, 6 minus 1, 6 plus 2, 5 minus 1, 5 plus 2. It's a combination set of like 3, 6, 5, -1, and 2. Going through each combination, it's n. And you multiply by n. Another n is because in each combination, say for 3, you are going through the whole loop of like 6, 5, -1, and 2. And for each combination of 6, it's going through the list of like 5, -1, and 2. And that's been represented by this n over here. But for the n over here, it's represented by each combination of 3, 6, 5, -1, and 2. And for this number 2, it's a single sweep as we discussed. I believe they only talk about like the method 1 and the method 2. So yeah, there you have it. Everything comes to an end.